Hi, Professor Dutta. My name is Anirudh Tharagopan, and this video is part of our final project for the Big Data class. So, for this assignment, we have for this project we are doing data analytics using PySpark. So, we have taken the bicycle dataset. So, it basically has three datasets. The first one has information about all the kiosks. So kiosk is something where we keep the bicycles. It's kind of a place where bicycles are parked. So we have ID, we have a specific name for the kiosk, and then the status, whether it is active or closed, and then we have the latitude, longitude, and the location. And the second dataset that we have is information about each and every trip. So for every row, we have information about the actual trip, like what the checkout time, what the check-in time, and what specific ID was it, and then what is the trip duration, month, and year. And then finally, we also created one more dataset called customer data, which has information about, sorry about that, which has information about membership, bicycle IDs, the age range for that specific user, and what his gender is, and what the payment type that he used to do. So this data set we created by ourselves. We created using random data because we had three scenarios, and in the third scenario, we wanted to predict what kind of membership that specific member can be assigned. So we have totally three scenarios. So we wanted to do data analysis on these three scenarios. So I'm going to explain about the first scenario where we want to predict what the average rental duration for each bicycle for a given period. So basically, like a description for this specific scenario is like wear and tear is inevitable to both bicycles and kiosks. So the aim of this use case is basically used is to calculate the average rental duration of each bicycle for a specific period with the assumption of that there should be some positive correlation between the distance travel and the rental duration. So that would be our specific assumption. So we have a few more assumptions as well. Like we're going to take 2016 as 1 year. Only that year alone we are going to try to predict what the average rental duration is. So we have taken all the specific packages that are required here, and then I'm creating the Spark context object here, and then I'm uploading all the data sets that are necessary. So now the average rental duration is I'm taking this specific period, and what I'll try to do is basically I'm going to filter only 2016 data and remove the records with empty or null bicycle ID, so which I would be doing it here. And then I'll also find the total trip duration per bike per day, which I can do by doing lambda v1 comma v2. I can add the total trip duration per bike. For each bike there will be a total trip duration. And then after this I need to create a flat map. I'll flat map the RDD to create two records per trip. So for each bike ID I'll have a checkout date. I'll have two records. One will be the checkout date and the other will be the duration minutes. So once I have two flat maps, I can do the total. I can calculate the total trip duration, and then I also can count the total number of trips, which I can do it here, right here. And then finally, I can produce the expected output. I would be selecting specific rows. So I would be taking the bike ID, the number of trips that bike has taken, and the total trip duration and the average rental duration. So that would be the actual output that is required here. So I have the bike ID here. I'd be selecting these so that for each bike I can see that okay, so this would be the number of trips that this bike has taken, and this would be the total trip duration, and this would be the average rental duration, and I have sorted it and taken the top 5. So now my friend Sanket would be explaining about the second use case.
So this is the second use case which we will be going to do. So what is the question here is how can B-Cycle, that is a company, identify the most or the less frequency use case to rotate the bicycles so as to even out the wear and tear across the fleet. So this application will be in the preventive maintenance mainly. Like let's consider a situation like there are two kiosks, like where there are a lot of bicycles being rotated, like, but there are few kiosks where there are very few number of bicycles being rotated. So what happens is in the most frequently used kiosks, the cycles are used a lot of time, and it results in the wear and tear, and even it results in the poor customer experience and as well as the high maintenance cost. So what is the aim of this use case is to identify such kiosks which have the very low levels of usage and rotate their bicycles with those kiosks which are the high levels of usage. So I'll just walk through the code here. We're importing the necessary SQL functions as function, and this is the schema part here. We are defining two schemas here: the trip underscore schema with the structure type and the individual field type, and similarly the schema. So before this, there are a few assumptions which we have considered. So first is to achieve this preventive maintenance, we'll first identify the best and the worst three kiosks based on the rental usage. The bicycles from these two groups, that is the worst and the best, should then be rotated. So we will do this preventive measure for the month of March 2016 only. And while doing this analysis for each of this month, we'll assume that each month analysis is not dependent on the preceding months. Let's consider the scenario here, considering that it is the last day of this month, that is March 2016. So the B-cycle company wants to know which KSK the bicycles they should rotate for the next coming month. That is the next coming day, that is April 1st. So what we're doing here is, as told, we are first creating the schema for the trips data frame, and the next is we are creating here. What we're creating it is the data frame for the trips and KSKs using the trip schema and KSK schema. With the header as false, meaning to read the first row as a data and the null values as NA. So next we are using the data frame filter operation to filter only records from the March month of the year 2016, and also the assumptions which we made also tells us the same thing. Next in this trips checkout check-in thing, we are basically using the group by on checkout kiosk's ID, and then use the aggregate functions on the above filtered data to get the count of the check-in and the checkout activities that each kiosk experienced in that month. And in the top three checkout, so what we are doing here is we are running the query to get the top three kiosks for the checkout or check-in activity by counting the checkout kiosk ID and the return kiosk ID, and using it as an order by and putting it as descending and limiting it for only three, as you want only the top three. Similarly, we are doing this for the bottom three, and as you can see here we are creating a RDD bottom three union, uh, and you are unioning this three bottom three checkout and bottom three check-in, since we're interested in knowing only the least performing kiosk. And then we are selecting the distinct on this, the distinct on the return kiosk ID, and then we're renaming it as kiosk ID list activity. And what we're doing is we're joining the created above bottom union with the chaos case on the common key, that is the list ID activity from the above created ID and the chaos case ID from chaos case, and then we are selecting only these two columns and displaying them. So the output of this query is here, which tells us that these are the top four or the three worst performing chaos case. Thank you.
Hello, Professor Dutta. Now I'll be going through the data exploration and visualizations, and just for that, we have read the whole bicycle trips data file into Pandas data frame for better analysis and exploration of the data. As we can see, I've already uploaded, and I'm viewing the Pandas data frame here. I have imported necessary libraries here, and we plotted the whole data set, as we can, using the membership count here. uh, as we can see, the most number of membership counts are local 365, and the next best is local 30, weekender and prohibited. One interesting fact to see is that most of the customers are not prohibited from receiving any kind of memberships, which is really good. And here we have just plotted a histogram to show the maximum number of checkouts and the more frequency in which kiosks. That is Third Invest. These are the different kiosks. Now I'll be moving to the k-means modeling part. So for k-means modeling, again I've uploaded the data as a text file. I've showcased the data set here. Then here we are removing the header for bicycle kiosk. Then I'm filtering out for only 2016 because we want to perform analysis on only 2016 records. And I've chosen the features of my interest among the many features present, that is membership type, age range, gender, and payment type with respect to fields here. And I've mapped the same using lambda functions. And here we are excluding walkup because that will be my predicting variable. In this, that is what is the main concern for us, is to predict for walkup members only, predict a membership type for walkup members only. And as we can see, I've again printed the whole process data here, which is the membership type, age, gender, and the payment type, the features which I have chosen for my analysis. Here, since everything is in a string format, I'm converting things into int. The membership type has been converted into int, and respectively all the features I'm converting into from string to int. And this is the final scaled data. Now I'm building my k-means modeling. I've assigned the model over here as I've initialized random generation for iter, and I've maximum iterations I've given is 20 for this. And I'm choosing the cluster members. So for cluster center, so what cluster centers does is it chooses all the features, and the features most reliable to these cluster centers will be clustered around these cluster centers. For one, it will be weekender. For two, it will be local 30, and for the rest, that is the three, it will be local 365, and all be appended in this list. And here, I'm gonna use walkup as my y variable, and I've filtered the same using a mapping function. And here I'm predicting the same with the model which I've chosen over here. And I'm printing out different records and the final prediction for the recommended membership using different features, that is membership type, age, gender, and payment type. And we get the recommended membership type for walkup members alone because we have chosen walkup members as y variable here.
Hello, now I'm going to explain the logistic regression part, our fourth use case. In this use case, we are going to use logistic regression to predict the most preferred membership model, not only for walkup, but for all the customers. Here I am reading the data set again. And I'm taking the top records to show. Choosing the features whichever is required for the model. Now I am converting this feature value into integer value so that it can fit the model. And now converting the data set into the pandas so that it can be further processed. Here I am just shuffling the data columns so that I will have the y variable as the first variable and independent variables next. Now I am printing the schema. Here I am separating the independent variables and creating a label points for them. Now I'm just mapping the independent variables, viewing the selected features here. And now I'm selecting the dependent variable, and I'm trying to create a mapper for that. Finally, after doing all the processing, I am splitting the data into training and testing data. I have selected 80% of training data and 20% of the testing data. I am trying to run the logistic regression, with a BFGS, and the number of classes here is 4. Here you can see the training data, and these are the weights of the model. Finally, in this training data, the values which we are seeing is like age, gender, and payment type. Now we can predict the membership type for a particular random customer. I mean preferred membership. Next, we are trying to find the metrics of the model. Here you can see we have print the recall and F1 score for the model, and here you can see the recall and F1 score are almost same, because the data set which we got is like it is almost perfect data set. Next, here these are the recommendations of our project. As we found the most used kiosk, this will be valuable to the operations team to rotate the bicycles accordingly and concentrate more inventory of these cycles in this kiosk. Similar to the above point, we found the lowest used kiosk for the checkouts, which can be valuable insights for the strategy and marketing team to focus more on sales and increase their rentals by using the various marketing strategies. As the most recommended membership predicted by the model or local 365, this will give the management team and marketing team to provide the particular membership if a new customer turns up. Model prediction also generated better insights for the most suitable and recommended membership is local 365 for the walk-up customers. And that's it for our project. Thank you.